Well, hello again, and welcome to part 4 of our test preparation for test 18. If this is exhausting you, again, you can fast forward through the types of problems that you already know how to work. Let's get started. First, we're going to look at a graph, and this is only an x-axis. Remember, x is horizontal, and we're going to write a conjunction that describes the graph. In other words, we're going to write an inequality. That means not equal. It might be equal, but it has a less than or greater than symbol. We want x to represent all of this dark space in between -2 and 3. I'm going to begin by putting my x under the bar or the spaces that x represents. X is in the middle. The number 3 is on the far right, and the number -2 is on the far left. X is between -2 and 3. Now x has to be greater than -2, but it cannot touch -2. It has an open circle, so it is not equal to -2. So if x is greater than -2, the alligator mouth faces the x, right? X also has to be on the left of +3. That means x has to be less than 3, and on 3 we have a colored in closed circle, so that means it can also be 3. It is touching 3. Now I have quickly written the inequality or the conjunction that represents this graph. Conjunction means to come together, and so x comes together between -2 and 3. Here's another example. Write the conjunction that comes between this -3 and this +1. We're going to write the conjunction as an inequality. I'm writing my x variable underneath the area or the place where x is. X can be anything on this solid line. X is between my number 1 and my number 3. Now on -3, it is colored in closed dot. That means that x can also be equal to -3, and x has to be everything above or greater than -3. If x is greater than -3, then the alligator mouse faces the x. But here I need x to be below or to the left of +1. If x needs to be less than +1, then the alligator mouth is not going to face the x if it is less than 1. It wants to eat 1 that is greater. All right, now I have written the conjunction that represents this graph. That's all they're asking for. The next type of problem we're going to look at are what we nickname stacked fractions, but they're really called complex fractions because we have fractions inside of fractions. Our main fraction bar is here. I need the whole numerator to be one fraction and the whole denominator to be one fraction. Then I can take my denominator and flip it into the numerator and just multiply. So I need common denominators. First, we'll look at this numerator. A is really A over the number 1. Anything is just itself written over the number 1. Now I can find a common denominator for 1 and A. A is my common denominator. The second fraction, B over A, already has an A in the denominator. So I'm going to change the first fraction, and I can multiply A times 1 to make the denominator A. But whatever I do in the denominator, I have to also do in my numerator. So I have part of my problem already done. I have common denominators. Now I can add these fractions, and they're both going to have A in the denominator. I just add my numerators. My first numerator is this A squared, and then plus the second numerator, B. My numerator is ready to go. Now I need to look at this denominator. I need to add 1 over a minus 4. Remember, minus is just plus a negative. 4 can be added to a fraction if I write 4 like a fraction. 4 is really 4 over 1. My common denominator is a. My first fraction already has an a. So let's make 4 over 1 have a denominator of a. I multiply times a. But whatever I do in the denominator, I have to also do in the numerator. I'm going to rewrite this denominator. I'm adding the fractions. They both have the common denominator of a. I'm going to add the numerators. 1 minus, and then I combine this 4 times a. 1 minus 4 times a. Now I have a whole fraction divided by a whole fraction. Now I can use my fun trick and take the denominator and flip it and multiply it times my numerator. Because remember, when a fraction is divided by a fraction, you can flip the second one and multiply. I'm going to rewrite this. My numerator, a squared plus b over a, can now be multiplied by the flipped denominator, 1 minus 4a. I can multiply this right away. Just multiply my numerators going across and my denominators going across. I need to remember that this binomial stays together and this one stays together. If I multiply, I distribute, but I don't want to multiply. Why not? Well, if I reduce first, it is so much easier than reducing after I multiply. I can recognize that I have a factor a in the numerator and a factor a in the denominator. We reduce fractions by finding what we can divide into the top and into the bottom. A divided by a is 1, and a divided by a is 1. I divided the top and bottom by the same term a. Now when I multiply my numerators, all I have left is a squared plus b. I multiply my denominators and I have 1 minus 4a. This is my answer simplified. I took this complex fraction and simplified it. The last thing I want to go over is how to work functions. This g of x is a function called g. Okay, I want to take this function g. Now this does not mean multiply g times x. This is the name of my function. My function is just naming this phrase or equation. It tells me that my variable is x. So this x value tells me that what my variable is, and when they rewrite it with a -2 there instead of an x, that tells me to substitute -2 everywhere I see an x. So I'm going to rewrite this equation. G, now instead of x, I want to substitute -2. So I'm going to write g of -2 equals, now I'm going to write the expression, but everywhere I see an x, I'm going to write a -2. Remember, this is called showing my work. We need to show our work. Even though we can do some of this in our head, showing our work prevents careless errors. I can simplify this now and find out. See, I'm trying to find g of -2. I can find g of -2 by using my please excuse my dear Aunt Sally, bless her heart. We're going to start with parentheses and exponents. Okay, so I have an exponent with this first parentheses. That tells me that -3 is times -2 squared. That means -2 times -2. So that would be negative 3 times 4. There are no other exponents, and so now we can do our multiplication. Negative 3 times negative 4 is negative 12. 2 times negative 2 is negative 4. And then minus 5 is the same thing as plus a negative 5. Now I have 3 negatives. They are not multiplied now. I am ready to add. When we add negatives, we just get a bigger negative. So my answer will be a big negative number. It will be negative 12 plus 4, that's negative 16, plus negative 5. So I end up with negative 21. All right, I hope this helps you. Good luck on your test.